Hello everyone. In this video, I will be interpreting a regression result. In the last videos, we learned about regression and correlation. In the last video, we theoretically understood the regression analysis. And in this video, I am explaining a regression result or regression output. You can see when you run a regression in Excel or other softwares, you will get somewhat these results. So first number or first statistic we are interested in a regression result is R square. Okay, this is R square. For example, here it is 0.875. I discussed in the last video that R square indicates how much variation in the dependent variable is explained by the independent variable. Keep it in mind that this is a bivariate regression result, and in bivariate regression, what we try to do is we try to explain the variation in dependent variable by an independent variable. Question is how successful we have been. So when R squared is 0.875, it indicates that 87.5% variation in our dependent variable has been explained by the independent variable we included in the model. Or in other words, we can say that 87.5% of the variation in the dependent variable is coming from the independent variable, or 87.5% variation in the dependent variable is accounted by the independent variable, and remaining 12.5% variation is attributed to some other variables. So R squared is the first number we look at. The next we look at the p-value corresponding to the F statistic. So this p-value basically indicates how significant the model is, or overall whether we have been able to substantially explain the variation in the dependent variable by the model. And if this p-value is less than the significance level, for example, here you can see it's 0, so it's less than the significance level of 5%, so the model is significant. So model significant means the regression model that we are estimating, it has been able to explain a substantial portion of the variation in the dependent variable. The next numbers we will look at the coefficient and the t-statistic and p-values. So first of all, if we look at coefficient, for example, number of building permits is our independent variable and dealer sales volume is the dependent variable. So it has a positive coefficient, 0.546. So positive coefficient indicates that there is a positive relationship between number of building permits and dealer sales volume. So we can say that increase in number of building permits will increase dealer sales volume since there is a positive relationship. Okay. What's the other interpretation? Another interpretation is the correlation, the coefficient is 0.546. It indicates that 1 unit change in the number of building permits will change dealer sales volume by 0.546 unit. That means this coefficient indicates that for a given change in the independent variable, how much the dependent variable will change. Okay, I repeat, this positive correlation indicates a positive coefficient indicates a positive relationship between number of building permits and dealer sales volume, and 1 unit change in number of building permit will cause a 0.546 unit change in the dependent variable, for example, dealer sales volume. So this coefficient tells us the direction of relationship and also how much the dependent variable will change. Now the question is this relationship statistically significant? Is it statistically valid? We can answer this question by looking at the p-value corresponding to this coefficient. And you can see this p-value is 0.00. So if this p-value is less than the significance level, it means that the variable is significant, or the coefficient is significant. Coefficient is statistically significant. It means that this independent variable has a statistically significant impact on the dependent variable. Is that all right? Now, how this this is the OLS regression line. We also discussed it in the last video. Now, how this regression analysis helps us in hypothesis testing. So as I previously mentioned that in regression analysis, we try to find out if X has an influence over Y, or if X is explaining Y, or if X is explaining the variation in Y. Now, as far as the hypothesis is concerned, we may have a hypothesis like brand loyalty affects customer satisfaction. Or we may have a variable like level of income determines level of expenditure. We may have that degree of economic growth or degree of economic development depends on the literacy rate. So in each of these cases, we may develop a hypothesis. For example, customer satisfaction has an association with brand loyalty, or customer satisfaction has an association with price level. Employee satisfaction does not have an association with salary level. Employee satisfaction has an association with salary level. Income level has an association, does not have an association with expense. Income level has an association with expense. Okay, so if we have this type of variable and we run a regression, if we accept the null hypothesis, that means there is no association, and if we reject the null hypothesis, it means that there is an association. That means the independent variable having an influence over dependent variable. And how we actually look at the statistical significance. So once again, we run a t-test here. When we have a regression coefficient, for example, 0.546, we run a t-test. We run a t-test with a null hypothesis that this regression coefficient 0.546, this regression coefficient is equal to 0. That's our null hypothesis. Now, if we accept this null hypothesis, it means that regression coefficient is same as 0, so the variable doesn't have a significant influence over the dependent variable. However, if we reject this null hypothesis that regression coefficient is equal to 0, if we reject this null hypothesis, it means that regression coefficient is significantly different from 0, so the variable has an influence, independent variable has an influence over the dependent variable. So this is the way regression analysis helps us finding out the relationship between two variables, and it helps us testing hypothesis. So this is the end of this video, and as well as end of a discussion on week 9. So continue to watch videos in next week for a discussion on our subsequent topics. Thank you very much.